So let's start. No, I don't know what rule is that. I don't think it's applicable. If it's engineering, math and above, it's not secondary school level, then I will not know. I never even see this before. Even when I do calculus, I also never see this before. Okay, let's start. So the first part is to do proving. So this one, we will definitely start from the left-hand side. So we will have left-hand side is equals to sine 2x over 2 cosine x. Just copy the question first. Okay, the right-hand side is just for your reference to know, like, okay, sometimes you can have more than one choice, then you have to decide you want to change to what. Okay, this one, look at the right-hand side, is single x. So it means that my left-hand side, when I have double angle, I'm going to apply the double angle formula to change them to 1x. So you can see that over here, I only have this sine 2x, which is double angle. So looking at the formula sheet, we have sine 2a is equals to 2 sine a cosine a. Okay, so we have sine 2a is equals to 2 sine a cosine a. So we're going to use this one. Okay, I'm going to write at the side here, so it's easier to see. So formula list state for sine 2a equals to 2 sine a cosine a. So it means that I'm going to change the sine 2x to become 2 sine x cosine x over 2 cosine x. So what I change is only the numerator. So this one I no change, don't change first. Okay. Sorry, Aki, I cannot help you with that. Okay, so then after that, cancel the 2, cancel the cosine x. You left with sine x minus sine x cosine square x. Then you look at the right hand side. The right hand side is purely sine, so it means that I can change my cosine square x. So we're going to use this identity, which is sine square a plus cosine square a equals to 1. This is the first identity, which is in the very first one. Sine square a plus cosine square a is equals to 1. So I want to make cosine square x become sine square x. So what you need to do is you make cosine square. Okay, I should use red color. You should make cosine square a the subject. So it should be cosine square a equals to 1 minus sine square a. So you see, I make cosine square a the subject, means I can replace my cosine square a to become 1 minus sine square a. Okay, so what I'm going to do is I write sine x minus sine x bracket, change the cosine square x to become 1 minus sine square x. Okay, this one no change, no change. This I'm going to rainbow. So minus sine x times 1, so it's minus sine x. Minus minus, so it's plus. Sine x times sine square x is sine cube x. Sine x minus sine x disappear, so I only left with sine cube x, which is exactly the same as my right hand side. So it's shown. Okay. Wow, so I have people who have doing higher level of math here, is it? Oh, you are smarter than me. Oh, okay. Well done. It really to be like that. Thanks for helping the app here. I cannot help him. Okay, so now over here, okay, kids, you see, over here, if you cannot even do the proving, okay, if you cannot even do the proving here, you should also straight away just do the part 2. Okay, touch wood, if you cannot do part 1, don't skip. Don't do part 2. Because they say hence. Hence means that you need to refer to the first part. Okay, differentiate this one. So this one on the part 1, you can see that we have proved that this is equals to sine cube x. So you can just straight away differentiate this. So in other words, if I want to differentiate, I can straight away differentiate sine cube x. Okay, so differentiate sine cube x, how do you do it? So for me, for Trigo, right, when the square cube is in the middle, I will change my presentation so it's easier to differentiate. So this actually means it's sine x to the power of 3. Okay, so I was supposed to differentiate this. So actually I'm applying chain rule. I will have to apply chain rule. So differentiation of chain rule is bring down the power, which will be 3. Then after that, this one copy, power minus 1. So 3 minus 1 is 2. Multiply by differentiate the inside. That means differentiate sine x. It will give you cosine x. And differentiate the theta. Differentiate x is 1. So times 1. So actually there's 2 level of differentiation. You differentiate the inside, differentiate the theta. Okay? Okay. So then after that, simplify. So now, of course, this square you have to put back to the normal rules of how you should present for your Trigo. So this should look like 3 sine square x cosine x. And you're done. Okay? So this is how you differentiate. Okay, and then I'm going to talk about differentiation of the Trigo, the three things that you need to remember. So when we want to differentiate sine x, you need to know it is cosine x. Okay, when you differentiate cosine x, it is equals to minus sine x. Okay, when you differentiate tangent x, it will be secant square x. Okay, so don't ask me how to derive this one. I only know how to use it. So you have to memorize this one. You have to memorize this one. Okay. So take note, one thing is sometimes, okay, let's for example, sometimes there's a question, let's say for example, okay, they ask us to, this one is additional, additional. If they ask us to differentiate, for example, secant square x, then student wonder, how to differentiate? Actually, there's 2 ways of doing it. 2 ways of doing it. 2 ways. You can actually change this the identity, because take a look at this identity. We have secant square a equals to 1 plus tangent square a. So you actually can change the secant square to become tangent and differentiate as per like tangent. Or you can change it to 1 over cosine square also can. Okay. Okay, take note, let's focus here. Okay, so I think you can just drop your topic. Okay, no chit chat of other irrelevant. Later my moderator block you, I don't know. Okay, so differentiate of this one, I have 2 ways of doing it. Either I change this, okay, because I have the identity, so I can actually do it as an, okay, I want to differentiate 1 plus tangent square x. I can do that because secant square x is equals to 1 plus tangent square x. And differentiate this one, it will just be 1 plus tangent x square. I can do it in this way. Okay, let me continue here. So it will look like differentiate 1 is 0, no more. This one, apply the chain rule, bring down the power. So it's 2 tangent x 1 multiply by differentiate inside, which is secant square x. Okay, and this one is 1, so it's times 1. So in the end, I get 2 tangent x secant square x. That's one way. Okay, another way, alternatively, you can also say, okay, I want this to be differentiate 1 over cosine square x. Because third letter C means it's 1 over cosine. So if I rewrite this, it is differentiate cosine x to the power of negative 2. Right? I also can differentiate in this way. Then apply the chain rule. Power bring down, minus 2, copy. Power minus 1, which is minus 3. Multiply by differentiate inside, which is minus sine x. Then times the differentiate inside, which is times 1. So when I simplify this, I will get minus minus is positive, so I get 2 sine x over cosine cube x. Okay? So actually I can split this. I actually can split it. If I want to make it to be exactly the same, I can say it is 2 sine x over cosine x times 1 over cosine square x. Then it becomes 2 tangent x, and this is secant square x. You see, it's the same. It can be the same. So this way, I show you two ways to do it, right? So this one you can use the identity and change it to in terms of tangent. Because differentiation of trigo, we only have differentiation of sine x, differentiation of cosine x, differentiation of tangent x. Okay? Thanks for the rows. Okay? So two ways of doing it. Up to you, see which one you want to do it. Okay, so let's move on to the next question. Okay, let's square this up. Okay, let me just put, because this is not related to the top. This is just some additional question that I want to highlight. Okay, here. So now my y is equals to 4 sine, sine 4x, sine 4x. So I want to differentiate this. Okay, so differentiate sine 4x is very straightforward. My dy why I use red pen? Yeah, right here. Y is equals to sine 4x. So I want to differentiate this. So in front, remember I said differentiate sine x is equals to cosine x. So it's the same, it's also cosine 4x. But one more step, multiply by differentiate the theta. For this case, when you differentiate 4x is 4. So it's times 4. So in the end, it becomes 4 cosine 4x. Okay, they have a d square y dx square. Means I want to differentiate one more time. So it means that my d square y dx square, I will differentiate this 4 cosine 4x. Differentiate it one more time. Okay, differentiate one more time. So the differentiate cosine is minus sine. So it becomes this 4, I don't care. So this one is minus sine 4x. Don't forget to multiply by differentiate the inside, which is 4. So in the end, this one I get negative 16 sine 4x. So now I have my dy dx, I have my d square y dx square. They ask you to prove that d square y dx square times dy dx is equals to this. So very straightforward, you will just write d square y dx square multiplied by dy dx is equals to this, will be this, which is minus 16 sine 4x multiplied by dy dx, which is 4 cosine 4x. So I will have minus 64 sine 4x and cosine 4x. So you can take a look that the theta is the same. One sine, one cosine means I can make use of the double angle. So what I'm going to do is, I just put minus 32, 2 sine 4x cosine 4x. See, I put the 2 inside the bracket because our formula, again, for the double angle, sine 2a is 2 sine a cosine a. There is a 2. So what I did was I separate out the 2 sine 4x cosine 4x inside the bracket. So the minus 32 is outside. So it means that this part, so minus 32 sine 8x. Okay, see here, a, the left hand side is 2a, just times 2. So this is 4x, so 4x times 2, so it's 8x. That's why it's minus 32 sine 8x, which is exactly the one that they asked us to prove. So you will just say shown. Done. Okay, so this is how you differentiate trigo. Okay, let's move on. Okay, so they asked us to differentiate cosine 2x and tangent square x minus 1. So for this question, you can see that it is an expression x multiplied by another expression x. So it is, you have to use product rule. Okay, product rule. So it means that I have to keep the left hand side, differentiate the right hand side. So this differentiate right hand side is a bit tough, right? So what you can do is, I can do it separately outside. For me, is I always do that. So I want to go and do differentiate my tangent x square minus 1. Okay, I do it separately. Then after I just bring it back, so that it's neater also. So I want to differentiate this. So chain rule, this one bring down, so it's 2 tangent x power minus 1 multiplied by differentiate inside, which is secant square x. And when you differentiate, minus 1 means it's disappeared because it's a constant. So this part, it is just 2 tangent x secant square x. So now this one I can bring back here because product rule means keep left, differentiate right. And my differentiate right, I did it here. So I just put it back. So it will be 2 tangent x secant square x plus. Now I'm going to keep the right hand side, which is tangent square x minus 1. And differentiate the left hand side, which is cosine 2x, which will give us minus sine 2x. Don't forget to multiply the inside, which is a 2. Okay, so they mentioned that you don't have to further simplify it, but of course you need to still so-called remove the bracket and write out better neatly. For example, the number 2 of course must be in front. So you write it as 2 cosine 2x tangent x secant square x. Okay, and this one will be minus 2. See, I have to rainbow. So it's minus 2 sine 2x tangent square x and plus, because minus minus 2 sine 2x. Okay, you can leave it in this form. Okay, so this will be like that. Okay, so over here they didn't rainbow but you want to rainbow also can. So this is fine. That's for question 3. That's for question 3. Okay, let's move on. Okay, so this is a little bit, you see this one is 6 marks, 6 marks. So they say find the value of the constant k for which y equals to this one is a solution of the equation. Okay, so you can see that in this equation over here, you see y, you see dy dx, you also see d square y dx squared. So that means I need to do my dy dx as well as my d square y dx squared. So I'm going to write out my y first. My y is ex cosine x. So this is ex times cosine x. It means that I have to apply product rule to differentiate this. So I need to find my dy dx. Keep left. Differentiate cosine x is minus sine x plus keep right. Differentiate left. When you differentiate exponential is keep the same. Okay, multiply by differentiate, the power for this case is just 1. So let's simplify, and then okay, there's 2 terms whereby it has e to the power of x. So whenever you see such thing, you will take out the common factor. So you will take out ex, you will left with minus sine x plus cosine x. Okay, so that's my dy dx. Then let's continue to do my d square y dx squared. So d square y dx squared will be equals to, this is again ex, expression x multiplied by expression x. So you will use product rule. So keep left e to the power of x and differentiate the right hand side. So you want to differentiate minus sine x means is minus cosine x. Minus remain, I just differentiate sine x, which is cosine x. So it's minus cosine x. Differentiate cosine x is minus sine x. Plus, keep the right, which is minus sine x plus cosine x. And differentiate the left hand side, which is just ex times 1 again. Okay, so now I'm going to take out common factor again. I'm going to take out e to the power of x. Ex. So I will left with minus cosine x minus sine x minus sine x plus cosine x. And you can see that minus cosine x plus cosine x 0. I end up having minus 2 sine x. So it's become ex minus 2 sine x. So you can see that I have my dy dx ready. I have my d square y dx squared. And I also have my y. So now I actually can form the equation with all of these, okay, in order to solve the unknown k. Okay, so I'm going to just write here, So k, I follow the equation. Ky means k, this one. K e x cosine x plus 2 of the dy dx, which is this one. So it's plus 2 ex minus sine x plus cosine x, okay, equals to the d square y dx square, which is this one. So it is equals to minus 2ex sine x. So the question is, how am I going to do this equation? Solve this equation. Okay, if you take note, if you notice this part, from here to here, I actually have common factor e to the power of x. Okay, common factor e to the power of x. So I'm going to take out common factor. I'm going to take out common factor e to the power of x. So put a square bracket. First term, when I take out e to the power of x, I will left with k cosine x. Okay, and then I will have 2 and minus, so it's minus 2 sine x and plus 2 cosine x. Yes, close it. It is equals to minus 2ex sine x. Okay, this is just the right, this one, sine x. What thing? What question mark? You want to ask a question, you ask properly. You ask a question mark, I don't know what is the question mark for. Okay? So, you can see over here, okay? If you compare the left and the right, you see that here got minus 2 sine x ex, which is exactly the same as right hand side. Okay, exactly the same as right hand side. This is AMath. Okay? Then, you see that there's this extra. You don't have to make k the subject. You are like compare the coefficient. You can see that my minus 2 sine x ex is already here. And you notice that the right hand side doesn't have any cosine x. So what does that tell you? So that tells me that my k cosine x plus 2 cosine x is actually equals to 0. That means they must net off each other, because my right hand side doesn't have any cosine x. So you don't have to make k the subject, you're just comparing coefficient. So in this case, you can see that my k, therefore I know that my k is equals to negative 2, because minus 2 cosine x plus 2 cosine x will give me 0. And that's how we solve our k. Okay, so what I did is I find the expression for my y, which is given. I find the expression for my dy dx. I find the expression for my d square y dx square. And then after that, I will use all these three expressions to form the equation as per the equation that they state here. So just suck in, Then what I did was I compare the coefficient. But before I compare coefficient, what I did was I take out the common factor e to the power of x. So it's easier to see, Okay, it's easier to see. Okay, so we are done for question 4. One more question for differentiation of trigo, and we will go to do the, wait, is the other one is what? No, two more questions, two more questions on differentiation of trigo. Okay, this one. How do you differentiate cotangent for pi over 2 minus 2x? Remember that we only have differentiation of sine, differentiation of cosine, differentiation of tangent. So how do you differentiate cotangent for? Okay, how do you differentiate cotangent for? How you get 0? Oh no, because right hand side, you see right hand side, my right hand side is minus 2ex sine x. You see, there's no cosine x on the right hand side, correct? So it is actually 0 cosine x. That means there is no cosine x. And since my left hand side, I got two terms that have cosine x, it means that these two terms, when I add them together, it must be equals to 0. Got it? Okay? You understand why I get 0 now? Because right hand side doesn't have any cosine x term. So means the left-hand side, two terms must be equals to 0. Okay? Okay, so how are we going to differentiate cotangent 4? This is express AMath. Okay, differentiation of cotangent 4. So, what we're going to do is, you need to change them to in terms of tangent. So we know that cotangent is 1 over tangent. So this actually means that before I differentiate, I'm going to do on the right hand side. I'm going to change my cotangent 4 pi over 2 minus 2x to become 1 over tangent 4 pi over 2 minus 2x. And I'm going to change this to tangent pi over 2 minus 2x to the power of negative 4. Okay, so I need to change this to become this first. Then I can start to differentiate. Okay, so differentiate this is simply bring down the power. So it means that I have to write out that I change this to become tangent pi over 2 minus 2x to the power of negative 4. Because it's at the denominator. Okay, when you bring it up, become cos bring up. Yes, correct. Then it become negative 4. Okay, so now you can apply chain rule to differentiate this. Power bring down, so it's minus 4. Tangent, copy, 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 copy. Power minus 1, which is minus 5. Multiply by differentiate inside, which will be secant square pi over 2 minus 2x. Multiply by differentiate the theta, which is minus 2. Take note that pi over 2 doesn't have any x. So pi over 2 in this case is constant. So when you differentiate, the theta is actually just negative 2 because minus 2x. Okay, so all you need to do is just simplify. So let's see, I have minus 2 and minus 4, so it's 8. So this one is positive, so I have 8 secant square pi over 2 minus 2x. This is minus 5, so I just need to bring it down. So it's just over tangent 5. Okay, power 5 put in the middle. And this is pi over 2 minus 2x. Done. Okay, you don't have to further simplify. This is good enough. This is fine. Okay, so what I did was I changed my cotangent to be in terms of tangent. Okay, and then after that apply chain rule. So always remember, differentiation of trigo is tricky. Why? Because it has, like, you know, like it has many layers, like the onion, it has many layers. You differentiate as per the big outside, then differentiate the inside and the further inside. So it's like inside and theta. So students always get this confused. So I did was I differentiate the inside, which means I have to differentiate tangent. That gives me my secant square. Then when I differentiate the inside again, and that's how I get my minus 2 here. Okay, I think this times negative 2 I have to put a little bit further. Times negative 2. This one belongs to here one. It's continuation. It's nothing to do with this question. Nothing to do with this part. Okay, so that's for 5A. Okay, let's take a look what is 5B. See whether it's related. Okay, it's not related. Okay, let's take. Okay, 5B is given that the curve has the equation blah blah blah. Find the gradient of the curve when da 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 da. So all of you must definitely know that when they say gradient of the curve, it represents dy dx. So in other words, they're asking you to find the dy dx when x is equals to pi over 3. And they mentioned to leave your answer in exact form. So they already trying to hint you that means it's something to do with special angle, whereby it's the 30 degree, 60 degree, as well as the 45 degree. Okay, because those will give you the exact value. So let me write out the question first. This is y is equals to 3 sine 2x minus cosine x. So let's do our dy dx first. Okay, so to differentiate sine 2x. The 3, just put it there, no need to change anything. So I differentiate my sine 2x, which is cosine 2x, multiply by differentiate the theta, which is 2. Differentiate cosine x itself is minus sine. So actually this is minus bracket minus sine x. So to simplify, I will have 6 cosine 2x plus sine x. Okay, then now I'm going to start in x is equals to pi over 3. So we are supposed to start in x is equals to pi over 3. Pi over 3, you need to know that is 180 divided by 3 is actually 60 degree. Pi over 3 is 60 degree, so it's actually special angle. So I will have my dy dx equals to 6 cosine 2 bracket 5 over 3 plus sine pi over 3. Okay, for me, when I see pi over 3, I know that it's 60 degree. So at the side here, okay, I'm going to do this working. So sine 60 degree, we all know that it is square root 3 over 2. You are supposed to memorize the 9 ratio. Okay, now is this one. What is this? 2 times pi over 3. Okay, so first you need to know that 2 pi over 3 represent 2 pi over 3. In terms of degree, it is actually 2 times 180 degree over 3. So which is 120 degree. So this one, I need to find out what is cosine 120 degree. Okay, all of you should know by Trigo that 120 is obtuse. Okay, 120 is obtuse. It actually goes to the second quadrant. And in second quadrant, cosine is negative. So this is equals to minus cosine. 120, when it goes to the second quadrant, the basic angle is 60 degree. So it's minus cosine 60 degree. And our cosine 60 is half. So this is equals to minus half. So I do the working here, and then I know, oh, okay, so this part here, this part, this is negative half. Understand? So it will be equals to 6 bracket negative half plus square root 3 over 2. Which will give us minus 3 plus square root 3 over 2. Done. Okay, see? Okay, so this is how I do my 5B. Okay, so for those who are new here, you know that I have the TikTok live will be uploaded tomorrow onto the YouTube channel. Okay, and the worksheet PDF will be uploaded to my Telegram channel. So remember to go to my bio, click on the link there. There's only one link there. Click on the last button to go to my Telegram channel. The PDF will be uploaded there. Then after that, the second last button is go to my YouTube channel. Okay, so like if you find that I'm going too fast today and you want to recap and revise, you can always go back to the YouTube channel, my YouTube channel, and go and find today date 24th of April, the TikTok live, and then take the PDF that you get it from the Telegram channel, and then after that we play the video on the YouTube channel, and then you can just revise and recap and try the question yourself again. Okay? Okay, so we are done with differentiation of Trigo. I'm going to do rate of change. So who over here needs help with rate of change? Who feel that our rate of change is so difficult? How do you do it? How do you do it? Okay. Any more question on this 5D? If not, let me move on to our rate of change already. Rate of change. Many people, okay. Application of differentiation. There's many. We have stationary point, we have maximum minimum, we have increasing, decreasing function, we have secondary higher derivative, and then what else? Normal tangent. So and of course rate of change. So among all the application of differentiation, okay, rate of change is the one that is the more complex one. But actually it's not that tough after all. They cannot change the question too much also. So now let's start to do this question. So first, let's read the question. Okay, the variables of x and y are related by this equation. Y is equals to ln 5 minus 2x. The y coordinate of the point is decreasing at the rate of 0.125. So this one means is they give me dy dt is equals to minus 0.125. They did not say it's negative 0.125, but they say it's decreasing. So you automatically must put minus on yourself. Honestly, I prefer Sec 4 AMath topics over Sec 3. Actually, Sec 4 AMath topic, right? The main is differentiation, integration, and eventually kinematics, and then also got a proof of geometry. So it's basically you don't have many topics, but yet it has many portion, like application got different, and integration also have different. Okay, but so in other words, if you cannot understand differentiation or integration, then it's like, oh, your Sec 4 all the topics gone case. Okay, but if you master your how you differentiate and how you integrate, okay, and follow through, then you will actually get a lot of marks from differentiation and integration and kinematics. Understand? Okay, let's continue. This is units per second. They ask you to find the y coordinate of the point at the instant that its x coordinate is increasing, blah blah blah. So this one, they tell me my dx dt is equals to, increasing means positive, so it's just 0.1 units per second when y equals to question mark. Okay, commonly is they ask you to find, maybe say dx dt equals to question mark when x equals to something. That's the common question that they ask. So this one a little bit tricky is, first they did not tell you is asking you to find the x. They ask you to find the y. But you don't have to worry. Why? Because we do have an equation that relate between your y and x. So I can find, once I have my x, I just need to sub it in to find my corresponding y. That's all. Okay? Thanks, Faith. Okay? So now with this, look at this. dt. So I have these two terms, which is dy dt and dx dt. So you know that you need dy dx. So I'm going to do my differentiation. So my dy dx, differentiate ln is 1. So it's 1 over 5 minus 2x. And always remember to differentiate the inside. So differentiate 5 minus 2x give me minus 2. Hello, Faith. Okay, so it's multiplied by minus 2. So it becomes minus 2 over 5 minus 2x. Okay, so now I have my dy dx, I have my dx dt, I have my dy dt. So you need to form the connected rate of change with the three terms. Okay, so always remember that, so I will write it, something equals to something times something. So you have to put in accordingly. The one that without the dt is always in the middle. So that means my dy dx is here. Okay, hello. Okay, then this one is dy, so bring it on my left hand side, it will be dy dt. Then this side will be dx dt. Understand? So this is the very crucial, because if you put them in the wrong placement, that means you got it wrong already. So always put in the one without the dt in the middle first. So it's dy dx. Then look at the numerator. Numerator is dy, so that means dy dt is on the left hand side. Then right hand side is dx dt. Okay, so now let's put in the information that we have. Dy dt, they tell me is negative 0.125. So it's negative 0.125. This one I don't have, but I have the expression here. So it's minus 2 over 5 minus 2x. This one, dx dt is 0.1. So it's times 0.1. Okay, so actually it's just like solving algebra. If I want to solve this, okay, it means that I'm going to make this a subject. Means minus 2 over 5 minus 2x is equals to negative 0.125 divided by 0.1. So everyone see that? If I want to solve this, take it, this one is like a big x. If I want to solve this, I will take this divided by 0.1. So in the end, I get minus 2 over 5 minus 2x equals to, this one when you press the calculator, you get negative 5 over 4. So now it become two fractions, equal equation. So all you need to do is cross multiply. Okay, so cross multiply, I have negative 5 rainbow with 5 minus 2x equals to minus 2 times 4. So I have minus 25 plus 10x equals to minus 8. 10x equals to minus 8 plus 25. 10x equals to 17. X equals to 1.7. But don't stop there. Huh? Okay? But don't stop there. Huh? Sorry, this is my... I can only teach it in this size. I cannot do it portrait. Portrait is too small for me to write on my screen. So please try to use your PC to see. Okay, so x is 1.7. Don't stop there. Remember I said that this question is a little bit tricky. They asked you to find the y. They did not ask you to find the x. So you need to do one more step, is to find the y. So you need to sub. So therefore, my y is equals to ln 5 minus 2, 1.7, which is equals to ln 1.6. You can leave your answer in ln 1.6, or you can find the 3SF. So this is equals to 0.4700, round off 0.470, 3SF. Okay? So this is how you do this question. So if there's no question, we will move on to the second question. 0.47. Yes, it's 0.47. You got to put 0.470 because must put 3SF. 3SF. Although the 0 behind is redundant, but because we have to say that we round off to 3SF, so we have to put the 0 there to represent 3SF. If you put 0.47, it is 2SF only. Okay? Okay. Now question 2. Question 2. So now they say that, okay, let me find my paper first. Okay, some liquid is poured onto a flat surface and form the keyword is circular. Circular means circle. Okay, this circular patch is left to dry and its surface area decrease at a constant rate of 4 cm square per second. Sometimes you look at the unit, this one is cm square per second. So you know it is area dA dt. So I'm given dA dt is equals, again the keyword is decrease, so it is equals to negative 4 cm square per second. So my dA dt is equals to negative 4 cm square per second. Then they say that the patch remains circular during the drying process. Okay, so they're trying to it will still remain a circle. Find the rate of change of the circumference. So this one asks you to find dc dt. I let c be the circumference. They ask you to find this when the area is 400. Okay, this question is not easy. This question is not easy. So, this is quite not the usual. Why? Because you see, I have the two terms. One is dA dt, one is dc dt. So if I look back and see, oh, I need to find a formula which is A in terms of C or C in terms of A. But I only have formula like area of circle is A equals to pi r squared. Circumference is C equals to 2 pi r. Okay, I do not have a direct formula that relates between my A and C. Then you have to find a way to form your own A and C equation. So how do you do that? The trick is you go and find A formula first. So I know my A is circle because it's pi r squared. Circumference in terms of r will be 2 pi r. So this is the trick. You will list them in this way. Okay, and then what you need to do is, what is common between them? The r is common. So it means that I'm going to make use of this one, make r the subject. So my r is equals to c over 2 pi. So with this, I can sub this into my a. So it becomes a equals to pi r squared. My r now become c over 2 pi. Do you see that? Now you see that. Now, oh, now I have the formula between A and C. Right? So this is how you so-called get rid of the, for this case, get rid of the error, and you want to link A and C together. Okay? So now I have A in terms of R. So I need to simplify this one a bit more. So this one is pi C square over 4 pi square. In this case, the pi, you just take it as alphabet first. Just take it as alphabet first. So you can see that this is pi square. Here got a pi. I can cancel. I can cancel the pi. I still left with 1 pi here. So A equals to C square over 4 pi. I will have to write this as 1 over 4 pi C square. Okay, I put it in this form is because I want to differentiate. I want to do dA dC. Okay, so I have to put it in the index form, whereby the constant I put it outside, which is the 1 over 4 pi, I put it outside. Then C square is my, with respect to C ma. So now we are ready to differentiate. Now I'm going to do dA dC. So power bring down, so 2 times 1 over 4 pi will be just 1 over 2 pi. Then C power minus 1 is just C. So this is your dA dC. Now kids, okay, I have my dA dt, I have my dC dt, I have my dA dC. So remember, we have to form the connected. So remember I say it is something equals to something. Yeah, this one too small, later I cannot squeeze in. Okay, something times something. Okay, and I always say the one without dt is in the middle. So that means my dA dC is in the middle. dA dC. Look at the numerator is dA. So that means this side is dA dt. This side will be dC dt. Okay, then after that, fill in the blank. dA dt I have, which is negative 4. Put it in. dA dC I have over here. Okay, so it is 1 over 2 pi C. Now the question is, what is my C? Later then we settle. Then this dC dt, you are supposed to find. So this one is supposed to be the unknown. Okay, then go back to the question. They ask you to find dC dt when A equals to 400. When A equals to 400. But the bad news is, I want C. So I need to do a little bit of working. So at this side here, my A, which is pi r square. So I know that pi r square is equals to 400. My r square will be 400 over pi. My error will be square root 400 over pi. Okay? I want my C. So I have to use my C. So my C is equals to 2 pi r, which is 2 pi multiplied by square root 400 over pi. Okay? So of course press the calculator, and then you will get 70.89815. So, so when they say find dC dt at A equals to 400, when I do all the working, A equals to 400 is represent the circumference is 70.89815. Then I can sub this into here. So it becomes minus 4 equals to 1 over 2 pi, bracket 70.89815. So again, just like algebra, you want to solve this unknown. Okay, this one we can actually press calculator for the decimal. So this one is 11.28379. This is minus 4 times dC dt. So therefore, my dC dt is equals to minus 4 divided by 11.28379, and you will get minus 0.35449. Round off to 3SF, negative 0.354. Then, you see, every time you see a negative, read the question. They want me to find the rate of change of the circumference. Okay, they did not mention, find the decreasing rate. If they say find the decreasing rate, then I will have to say, okay, the decreasing rate is 0.354, because the decreasing word represents the minus. But in this case, they only ask you to find the rate of change. So it means that I just leave my answer in negative. Okay, but of course, don't forget to put your unit, which is cm per second. Done. Okay, this kind of question often come out and then student will be stuck. Okay, they will, A and C, how to make into an equation. So now I teach you how to do it. So this is how you do this kind of question, okay? Okay, we're going to do the last question of rate of change, okay? So anyone want any further questions on this question 2? If not, I'll move on to question 3. Any more question? Okay, now let's move on to question 3. This is also a commonly asked question. Okay. So a cone, okay? Water is poured into an inverted circular. So you see, what I write here is very important, is poured into. Means my water will increase, right? So base radius 5, okay, height 15 at the rate of 10 cm cube per second. So I know it's positive. So it means that my dV dt is equals to 10 cm cube per second. Because if they say that the water is leaked out, then it will be negative 10. But now it is poured inside. So you know that it will be increasing. So it is positive 10 cm cube per second. Okay, they ask you to show that the rate of increase of the height of the water level is blah blah blah. So in other words, I want to find my dH dt equals to question mark. Your task, of course, is to prove that dH dt is this one, right? Okay, so I mean, in other words, I'm trying to find dH dt when height is 4. When height is equals to 4. So again, now you get to see what formula you need. So I have my dV dt, I have my dH dt. Means I need to form a formula which is V in terms of H or H in terms of V. So this one very straightforward. This is the volume of a cone. So it means that I need to use volume of cone formula, which is our V is equals to 1/3 pi r square H. Okay? Then I want you to do something, because I need V in terms of H, and you can see that this is V in terms of H and R. So I know that eventually I want to get rid of my R, but how? Okay, so every time you see this kind of question, you need to link it to similar triangle. Very important, you got to link it to similar triangle. How? We know that here is R, okay? Here is the height of the water. I label this as H. So similar triangles tells me that small over big, R over 5 is equals to H over 15. Very important. This is how you find the formula that relates between your R and H. Then because I want to get rid of the R, so I'm going to make R the subject. Cross multiply. I have 15 R equals to 5H. R equals to 5H divided by 15. Divide by 5, 1, divide by 5, 3. So my R equals to H over 3. Okay, so you see, I now have the formula that relates between R and H. And that's how I'm going to replace the R squared to become H. So it becomes 1/3 pi H over 3 square and H. Okay? Let's simplify. You're not ready to differentiate yet. So I have 1/3 pi, this is H squared over 9H. So always put a constant outside, so it becomes pi over 27 H cubed. This is my V. This is my V in terms of H. This is my V in terms of H. So now you can do dV dH. So let's do our dV dH, which is easy. Power bring down. So 3 times 1 over 27 is actually give me 1 over 9. So it becomes pi over 9 H squared. Okay, so this becomes my dV dH. Now I can form my connected rate. Again, something equals to something times something. Throw in my dV dH. look at the numerator dv, so this side will be dv dt, and this side will be dh dt. Throw in the numbers that you have. Okay, dv dt is 10, I put it in. dv dh is this one, which is pi over 9h squared. dh dt is the one that you're supposed to find, so I leave it as dh dt. And remember, they asked me to find dh dt when h equals to 4. This one very straightforward. Why? Because over here, I can straight away sub in my h equals to 4. Okay? Hello, May. Okay? This is Teacher May. Teacher May. Teacher May also teach maths. Okay, so over here, h squared. So what you're going to do is pi over 9, 4 squared times dh dt equals over 10. So now you want to solve dh dt. So this one actually you can press a calculator. No, wait. They want in terms of pi, so I cannot press a calculator. I need to manipulate it until I get in terms of pi. So let's see. This one will be 10 over 1. This one will be 16 pi over 9. What I did was I make sure I have single fraction. Okay, so I want to solve dh dt. So dh dt will be equals to 10 over 1 divided by 16 pi over 9. Okay, then change it to multiply. So it is 10 over 1 multiplied by 9 over 16 pi. Let's simplify. Divide by 2, I get 5. Divide by 2, I get 8. So I get 45 over 8 pi. And ta-da! You get 45 over 8 pi over here. Correct? Hello! You just you just wake up from your nap, is it? Elf noodles. I'm ending, the last question. Okay? So dh dt is equals to 45 over 8 pi. And this is what they asked me to prove. So just write cm per second, and then after say shown. Done. You just ended up in your life. That means you are scrolling, then after suddenly you see my life, is it? Okay, so this question, take note to remember that it's linked to the similar triangle. Yes, okay. And then this is how because when we do our volume, we have volume in terms of R and H. Then you know that you need to get rid of R. And this is how you find the formula that relates between your R and H. Because I want to get rid of my R, so I make R the subject, whereby I can change my R to become H. Then I will have purely V in terms of H. And once I have that, I can do my dV dH. And by now, you all should know how to connect the three terms together and sub in accordingly, and then you solve it. Okay? Yes. Okay, so that's all for today. Differentiation of trigo as well as rate of change.